In this slide, we're going to take a look at graphing a piecewise function. Now, a piecewise function is a function that is made up of two or more pieces that exist on specific domains. So the equations would be 2x plus 4 and 3, but 2x plus 4 only exists from negative 2 to 0, and 3 exists from 0 to 5. So this is going to be a function that's going to change as my x's change. Now the easiest thing for me to do is to find the endpoints of my segments and then connect them. Finding the endpoints is relatively easy. If I look at the first segment, 2x plus 4, I know that it starts at negative 2. So if I plug negative 2 in for x, well, 2 times negative 2 plus 4 is 0. So remember, I plugged in negative 2, I got out 0. Similarly, I'm going to plug in 0 for my x, since that's the other part of my domain. And 2 times 0 is 0 plus 4. So when I plugged in 0, my output was 4. So the 2 points that I'm left with are the endpoints of my segment 2x plus 4. So I'm just going to graph them. I'm going to go over to negative 2, 0. I'm going to draw an open circle there. I'm going to go up to 0, 4, and I'm going to draw a closed circle there. Now the reason why negative 2, 0 is an open circle is because x is not equal to negative 2. It's only greater than negative 2. And the reason that 0, 4 is a closed circle is because x is less than or equal to 0. So I'm going to connect those points. So that segment represents the first part of my piecewise function. Now for the second part, I'm going to look at my next equation, which in this case is just 3. Again, I'm going to find the endpoints. So I'm going to take the numbers 0 and 5, and I'm going to plug them into this function. Now, there is nowhere to plug in the 0 and the 5 because there's no x in my function. So when I plug in 0, since there's nowhere to put it, the y is only going to equal 3. And when I plug in 5, again, since there's nowhere to put the 5, the y is going to remain 3. That shouldn't surprise you that the 2 points have a y value of 3, because an equation like the one listed there should be a horizontal line, and those 2 points will be in a horizontal line. So now I'm going to graph the point at 0, 3. Now this is going to get a little hairy because it's a little close on my graph. It should be an open circle at 0, 3. So I really ran out of room. It's kind of tough to graph on here. And I can't move that up to the 0, 3. So I'm going to leave it right there for now. We'll just pretend it's at 0, 3. The other point is going to be at 5 over 3 up. 5, 3 up. So we'll go 3 up. That's going to be a closed circle. I'm going to connect those 2 points with a segment. Again, graphing on here isn't always the best. But what I have is I have a diagonal or an oblique segment that goes from negative 2, 0 to 0, 4. And then I have a horizontal segment that goes from 0, 3 to 5, 3. And you'll notice that this is a function because the 2 points that are on top of each other, in the one on top it's closed, the one below it it's open. So this would in fact pass the vertical line test. So let's try that again. Again, in this case, I have a piecewise function where I have 2 pieces. I have a piece with an equation of negative 3 that exists as long as x is less than 3. I have another piece whose equation is x minus 6 that exists from 3 to 5. So for the first piece, the equation of negative 3, I'm obviously going to take the positive 3 and plug it into the function. But the problem is I don't have anywhere to plug in the x. So again, my y is going to equal negative 3. Now that's an endpoint. So if I were to set up an x and y coordinate plane over here on my function, over here on my graph rather, I know that I'm going to have an endpoint at 3 over negative 3 down. And I know that that's going to be an open circle. That's a really big open circle. So let's make that just a little bit smaller. A little bit better. Now, I need to find a second endpoint. But the problem is, this domain only tells me that x is less than 3. So there is no other endpoint. This segment is actually going to be a ray because it's going to continue to the left forever. In order to determine the direction that it's going to continue, I need to plug in some other number. I need to pick a number for x that is less than 3 so that it will fulfill this requirement. So I can plug in, for example, 2 because 2 is less than 3. So if 2 is my x, again I don't have anywhere to plug in that 2, so my y must be negative 3. So for the first part of my function, I have a point at 3, negative 3, I have another point at 2, negative 3. I will connect those points with a line. I will draw an arrow at the end of that line to show that it continues forever to the left. Now please keep in mind that those points should be at negative 3. Right now it looks like they're more like at negative 4. Now with the x minus 6 function, I have 2 endpoints that I could plug in. So I'm going to take the 3 and plug it in. 3 minus 6 is negative 3. So I have an input of 3 and an output of negative 3. Now interestingly, that's at the same open circle that I had earlier. So that open circle is actually going to get filled in. So it's now going to be a filled in circle. Then I'm going to take the number 5 and also plug that into the function. So 5 minus 6, which is negative 1. So my second endpoint is going to be 5 as my input, negative 1 as my output. So I'm going to go over 5, put a closed circle at 5, negative 1, connect those 2 points. So in this case, I have what looks like a horizontal line extending to the left, and then I have a small diagonal segment that is extending to the right of that horizontal line. And that would be my piecewise function.